Now suppose I want to find out the value of the multiple coefficient of determination for this case. So as we all know, when there's a multiple linear regression, the coefficient of determination is called the multiple coefficient of determination. How do we do that? As we've seen in the previous video, for the case of a simple linear regression, the same thing happens here. We can write summary of stack loss dot lm dollar r squared, and we get the value to be 91.35%. That means the fitted model has an r square value of 91.35%. Suppose now we want to find the value of the adjusted coefficient of determination here. The adjusted coefficient of determination can be found in the same way by writing summary of stack loss dot lm dollar adjusted adj dot r squared, and I get the value to be 89.83%. The test of significance for this case can again be done by observing the values, the p-values of the fitted coefficients, and that can be seen from the summary function. So I write summary of stack loss dot lm, and I get these p-values for the corresponding betas. So I see that all the p-values here are less than 0.05, which means that they are all statistically significant in the multiple linear regression model and all significantly explain the variations in the dependent variable. Similar to the previous case where we tried fitting the confidence interval and the prediction interval, we'll try to find out the confidence interval for this multiple linear regression case. What we do is to first fit the values of the independent variable. So say new data is equal to data dot frame of, the values are air dot flow is equal to 72, say water dot temp is equal to 20, and acid dot concentration is equal to 85. Then I predict these values stack loss dot lm using the new data values, keeping the interval is equal to confidence. Thus, the fitted value is 24.5 and the lower and the upper bounds are 20.2 and 28.9 respectively. With this, we fitted a 95% confidence interval. The same can be done for the case of a prediction interval where I just have to replace this with predict and the same values of the new data enter, and we find that the predicted value is 24.5 and the lower and the upper bound values are 16.4 and 32.6 respectively. So we've seen the fitting of a multiple linear regression, the estimation, the coefficient of determination, the adjusted coefficient of determination, the significance test, the confidence, and the prediction interval in R. Thank you.